Welcome to Maths for You channel, a past question on pure mathematics from Oxford and Cambridge past paper. Determine the set of values of n for which n squared minus 1 divided by 2 and n squared plus 1 divided by 2 are positive integers. Let's do this part. N squared minus 1 divided by 2, n squared plus 1 divided by 2. And those are both integers, positive integers. N squared minus 1 divided by 2, n squared plus 1 divided by 2, positive integers. So for the n squared minus 1 divided by 2 and n squared plus 1 divided by 2, it's to be an integer. N squared minus 1, n squared plus 1 have to be even. Otherwise, it will be a fraction, so not the integer. So n squared minus 1, n squared plus 1 are even. Then n squared minus 1 and n squared plus 1 are even. Therefore, n squared is an odd. If it's n squared odd, n is odd too. So now it's n is odd integer. But n should not take 0. If it's 0, then a minus, it will be fraction. 1, it will be negative, and then again it will be fraction. And plus 1, the first one, n squared minus 1 will be 0. Therefore, it's a positive integer. That's n squared minus 1 over 2. Therefore, plus 1 and minus 1 cannot be. So n can't take 0, can't take plus or minus 1. But apart from that, n is an odd number. That's first part. And second part, a Pythagorean triple is a set of three positive integers, a, b, c, such that a squared plus b squared equals c squared. Pythagoras equation. Prove that for the set of values of n found in part A, the numbers n squared minus 1 over 2, n squared plus 1 over 2 from a former Pythagorean triple. So, right, n squared minus 1 over 2, n squared plus 1 over 2, form a Pythagorean triple. But before that, a squared plus b squared equals c squared. So I just put a little right angle triangle, ABC. The side opposite to A is A, opposite to B is B, opposite to C is C. And Pythagoras theorem says, so formula, a squared plus b squared equals c squared. So n is the first one, a equal n, and b equal n squared minus 1 over 2, c is equal n squared plus 1 over 2. Just take the a squared plus b squared, take left-hand side, substitute the values, n values. A squared, n squared, plus n minus n squared minus 1 over 2 squared. Then n squared, if you half square of half is 1/4. So n squared minus 1 squared. Then n squared, take 1/4 out, n to the power of 4, if you expand it again, n to the power of 4 minus 2n squared plus 1. Then remove the bracket, n squared plus 1 over 4, n to the power of 4 minus half n squared plus quarter. N squared minus half n squared is a positive half n squared. So 1/4 n to the power of 4 plus half n squared plus 1/4. So take 1/4 out, n to the power of 4, 2n squared plus 1. N to the power of 4, 2n squared plus 1 is a complete square. So 1/4 n squared plus 1 squared. But 1/4, the square root of 1/4 is half. So n squared plus 1 over 2 whole thing squared. That is the left-hand side. But a squared plus b squared equals c squared. That is what we have to prove. So the n squared plus 1 and the c squared. So a squared plus b squared is c squared. So therefore, n squared minus 1 over 2, n squared plus 1 over 2 are Pythagorean triples. Thank you. Please subscribe to the channel and share the contents with other students and follow other students. Thank you.